Hi, Mr. Richards here. Today's Grade 6, Unit 6, Lesson 8, Practice Problems Review. We're first going to draw a diagram of x plus 3 and a diagram of 2x when x is 1. So we're going to take up one spot for that x now. And so here's our x, and then our plus 3, 1, 2, 3, is there. And so it looks like our x plus 3, when x equals 1, has a value of 4. What about 2x? Well, we have 1x, and we have 2x's. And so here's our 2x, and when x is 1, this has a value of 2. What about a diagram of x plus 3 and of 2x when x is 2? When x is 2, I'm going to draw it 2 wide. So there's our x. Here's our 3. And so now our x plus 3 has a value of 5. And for our 2x, well, if each one is 2, here's an x, and here's an x. Our 2x has a value of 4. And if we keep going now, draw a diagram of x plus 3 and of 2x when x is 3. All right, well, each x now has a value of 3, so we're going to go 3 out. And here's x. And then our 3 is still constantly just 3. And so this time, x plus 3 has a value of 6. And for our 2x, 1x has a value of 3. Another x has a value of 3. And so 2x this time has a value of 6. They seem to be equal there. X plus 3 and of 2x when x is equal to 4. Well, here's a value of 4 for the x's. Our constant of 3. And so this time, x plus 3 seems to have a value of 7. When x is 4, here's 1x. Here's a second x. And so 2x, when x is equal to 4, has a value of 8. And then we're asked, when are they equal and when are they not equal? Well, they appear to be equal here in C, right? They were both equal to 6. And so they were equal when x was equal to 3. They had a value of 6. And for not equal, well, that was the rest of them, right? When x was equal to 1, they had a value of, let's go back up, 4 and 2. When x was equal to 2, if we look back at that one, they had a value of 5 and 4. And when x at the end here was equal to 4, they had a value of 7 versus a value of 8. So there was only the one time where they were equal, and that was when x was equal to 3. It produced in both expressions a value of 6. Now continuing on, in number 2, do 4x and 15 plus x have the same value when x equals 5? Well, if we look at 4x, 4 times 5 is going to produce a value of 20. If we look at 15 plus x, 15 plus 5 also produces a value of 20. And so for 2a, we can say, hey, that rhymes, yes. In B, are 4x and 15 plus x equivalent expressions? Explain your reasoning. For these to be equivalent, it would not matter what I put in for x, they would produce the same result. And so the best way to check this is to say, well, what happens when x equals 1? For my 4x, this becomes 4 times 1, which is 4. For my 15 plus x, this would be 15 plus 1, which is 16. And so are these two equivalent expressions? We're going to say no. And this should become clear as we look at 3 of what exactly an equivalent expression is. Check that 2b plus b and 3b have the same value when b is equal to 1, 2, and 3. Let's look at our 2b, or not 2b, sorry, 2b plus b. When b is equal to 1, that's 2 times 1 plus 1, which is 2 plus 1, which is 3. Okay, what about 2? 2 times b is 2 times 2 plus 2. That's 4 plus 2, which is 6. What about 3? 2 times 3 plus 3. That's going to be 6 plus 3, which is 9. And now let's compare that to 3b. 3 times 1 is 3. So far, so good. 3 times 2 is 6. That matches the other one too. 3 times 3 is equal to 9. So they do appear to have the same value. When I put in 1 to 2b plus b, I got 3. Same thing when I put it into 3b. When I put this in here, when I put the 2 in, I got 6 for both. When I put the 3 in, I got 9 for both. And so as we look to answer parts B and C, do 2b plus b and 3b have the same value for all values of b? And quite frankly, we can say yes. And for my explanation, 2b plus b can be broken down into b plus b plus b. That's, well, there's 3 b's there. And 3b, likewise, is just b plus b plus b. They're the same thing, just written 2 different ways. So are 2b plus b and 3b equivalent expressions? Yes, they are. They each give 3 times the value of b. And so 2 and 3 are just such great homework questions because they really show the difference between expressions that just sometimes happen to be equal, like 4x and then 15 plus x happen to be equal when x was equal to 5. The rest of the time they're not going to be, just like in those grids on the previous page. Compared to an equivalent expression, when you have 2b plus b and 3b equaling the same thing all the time because they're just the same expression, these 3b's written 2 different ways. All right, let's move on to a little bit of review now. 80% of x is equal to 100. Write an expression that shows the relationship of 80%, x, and 100. I like to write my 80% as a decimal on these, which is 80 hundredths, which is the same thing as 8 tenths. And so 80% of x, so 8 tenths times x, is equal to 100. And now we can use the equation to find x. We'll divide by that 8 tenths on both sides. 8 tenths divided by 8 tenths simply becomes 1. And so we will be left with x equals whatever 100 divided by 8 tenths is. Now if I multiply both these by 10, because I can't have that second number be a decimal when I'm dividing, that gives me 1,000 divided by 8. I kind of work my way backwards here. No, I don't want a square root sign. I want just a division. 1,000 divided by 8. 8 goes into 10 one time. Subtract the 8, we're left with the 2, bring down the 0. 8 goes into 20 about 2 times. Subtract the 16. You get 4 and a 0, and I love to see a nice even number here, because 8 goes into 40 5 times. You're left with a remainder of 0. And so 1,000 divided by 8 is 125, which means x here equals 125. So 80% of 125 is equal to 100, which should make sense. Three more questions today. Here we go. For each story problem, write an equation to represent the problem and solve the equation. Be sure to explain the meaning for any variables that you use. Jada's dog was 5.5 inches tall when it was a puppy. Now her dog is 14.5 inches taller than that. How tall is Jada's dog now? Well, if we look at T being the, let's say, current height. One equation that we could write is T minus the 14.5 inches that she's taller than the 5.5. So the current height minus the 14.5 inches taller than that is equal to the 5.5 that it was as a puppy. Now, if I just add 14.5 to both sides here, they gave us some clean numbers to work with here. This becomes just 0 there, and then T equals a half plus a half is 1. 5 plus 14 is 19. With the 1 is just 20 inches. And so, Jada's dog is now 20 inches tall. Lynn was lucky enough to pick 9 3/4 pounds of apples, which is 3 times the weight of the apples Andre picked. How many pounds of apples did Andre pick? Well, if P are the pounds that Andre picked, helps to establish that variable. Not sure if you can hear the car honking in the background here with my microphone, but anyways, 3P, 3 times the weight that Andre picked, was equal to the 9 3/4. And so now if I divide this by 3 on the left and the right side, 3 divided by 3 becomes 1. So whatever 9 3/4 divided by 3 is going to be our solution. And so we just take our time here. 9 times 4 is 36, plus 3 is 39/4, divided by our 3, which is the same thing as 3 over 1. Keep, and then multiply by the reciprocal, 1/3. And I know it doesn't seem like there's anything to cross simplify here. There is. Divide by 3 for both of these, you get 1, and then 13. And so, this is going to equal 13/4. And 13/4 is the same thing as 3 1/4. And so, Andre picked 3 1/4 pounds of apples. And so now, depending on the book that you have, you may have additional questions, or you may just be stopping at 5. And so if you have one book, I think you stop at 5. If you have a newer book, you may have these questions as well. So lucky you, right? Now, finding products. 2 3/10 times 1 4/10. Another way of looking at this is 23/10 times 14/10. And so if we were just to take 23 and multiply it by 14 and then worry about, or not worry, but figure out the decimal point later, 4 times 3 is 12. 4 times 2 is 8, plus that 1 is 9. We're now to the 10 spot. 1 times 3 is 3. 1 times 2 is 2. Add these things up. 2, 12, 3. We have 322. And if I take 10 times 10, I get 100. So this is 322 hundredths. And so, decimal point, tenths, hundredths. I can place my answer in here at 322 hundredths. If we follow a similar strategy here, we have 172 hundredths multiplied by 26 tenths. And so I'll solve this one over here. We'll just take 172 and multiply it by 26 and think about the place value in a little bit here. 2 times 6 is 12. 6 times 7 is 42 plus the 1 is 43. 6 times 1 is 6 plus the 4 is 10. Move over to the 2 in our tens place now. 2 times 2 is 4. 2 times 7 is 14. 2 times 1 is 2 plus the 1 is 3. And so now as I add these up, 2, 7, 4, 4, we essentially have 4,472 over the 100 times 10 is 1,000. And so now for this one, we have our tens, hundreds, thousands, but we have 4 numbers. And so we'll just backfill this in 2, 7, 4, 4. So 4 and 472 thousandths. As we continue on now, we essentially have 182 tenths here times 2 tenths. And so, if we take 182 and multiply it by 2, 2 times 2 is 4, 2 times 8 is 16, 2 times 1 is 2 plus the 1 is 3. 10 times 10 is 100, so I have 364 100ths. And if I look at decimal point, tenths, hundredths, but I have 3 numbers, 4, 6, 3. So 364 hundredths, or 3 and 64 hundredths. Then I have 15 times 1 and 2 tenths. It's essentially 15 times 12 tenths. And so if I take 15 and multiply it by 12, 2 times 5 is 10. 2 times 1 is 2, plus the 1 is 3. Moving to our tens place, 1 times 5 is 5. 1 times 1 is 1. Add these numbers up. 0 plus 0 is 0. 5 plus 3 is 8. 180. So this is 180 tenths this time, because 1 times 10 is 10. So now my decimal point in tenths, but now I need these 2 numbers here. And so I have a 0, an 8, and a 1, so 180 tenths, or just 18. Let's move on to this last question. Again, depending on your book, you may or may not have this question. Calculate 141 and 75 hundredths divided by 2 and 5 tenths. Using any method of your choice, show or explain your reasoning. I cannot have a decimal here. I need to move that decimal over one to the right, which is the result of multiplying by 10. But if I multiply one number by 10, I have to multiply the other number by 10. So this is 1,417 and 5 tenths divided by 25. And so now, 1,417 and 5 tenths divided by 25. See how this works out. We don't go into the 1 in the tens or thousands spot. We can't go into the 4 in the hundreds spot, but we can go into the 141. Let's see, 25, 50, 75, 100, 125, 5 times. Subtract away the 125. and we get a 6 and a 1. Bring down the 7. And this time we can go 25 more to get to 150, so that's a 6. Subtracting away the 150, we're left with a 7, a 1. Bring down the 5 and go 1 more to get to 175. Hey, it works. 7 times 25 is 175. We're not left with anything. So 56 and 7/10 is our solution here. That is it for this practice problems review. Good luck.